Hello class, this is a video tutorial on geometry part 4. In this video we'll be looking at the internal angle sum of polygons. A polygon is a mathematical term for any shape. It is more commonly used to name shapes that have 5 or more sides. So triangles and quadrilaterals are still technically polygons, but they are special enough to have their own names. These shapes, where it's 5 or more, is usually where we start referring to polygons. So these first 6 that you see, pentagon, hexagon, heptagon, octagon, nonagon, and decagon, if you pause and count the sides, this will have 5, penta, this will have 6, hexa, heptagon has 7, you can probably see the pattern forming here. But these are examples of regular polygons where the length of each side is equal. So I've drawn these as best I could so that the sides of each of these polygons are exactly the same. So these more correctly are, this is a regular pentagon, regular hexagon, regular heptagon, etc. But if the sides are not equal, they are irregular polygons. So more correctly, if I just put this in front, an irregular pentagon would be this one that I've drawn here. It looks kind of funny, but if you count the sides, there are still 5 sides in that polygon. I'll just reveal the rest here. You can pause and count the sides of these. They should all match the names. So this decagon, if we move this here now, this is an irregular decagon. Once again, pause and count it, you'll find that there are 10 sides. Now, what we're looking at in this particular video is that similar to the sum of the angle sum of triangles being 180 and the angle sum of quadrilaterals being 360, all polygons each have a particular angle sum. To know what that angle sum is, we follow this formula. It's 180 degrees times n minus 2, where n is the number of sides in that polygon. All right, we'll just demonstrate to you how we might use this in these 6 examples. You can pause and figure out the missing letter from each of them. Alright, so let's get to it. Now, in order to figure out first what this missing angle is, we first need to figure out what all of these angles would add up to. That is the angle sum of polygons. So let's write this down. The angle sum. Well, for this, if we count the sides, 1, 2, 3, 4, 5, it's going to be 180 times 5 minus 2, which is 3. That's going to be 180 times 3, 540. Now, because of this, all of these angles, 90 plus 90 plus 45 plus 218, and whatever this missing angle is, should add up to 540. So let's calculate that. 90, 90, 45, 218. So make this a little bit faster. All of this adds up to 443. So a degrees plus 443 should add up to 540. We can figure out what the missing value is by subtracting from 540. So A, this is very poorly drawn. A is supposedly 97 degrees. I apologize then for the drawing of this, because this is clearly not 97 degrees. It should have been up here somewhere. All right, all right. Let's keep going here. This one is a regular, well, let's first count how many sides there are. It is 1, 2, 3, 4, 5, 6. That is a regular hexagon. So if we find the angle sum, we just do it as 180 times 6 minus 2 is 4. So let's calculate that. 6 minus 2 is going to be 4. Gives us 720. Now, if we think about how many angles there are here, it's 1, 2, 3, 4, 5, 6. Now, because all the sides are the same length, it must be the case that all the angles are the same length. So this is going to be 6 lots of the angle B equals 720. So each angle is evenly divided into 720. So B must be 720 divided by 6. B is 120 degrees. So this one angle is 120, but all 6 of them are also 120. And if you add them all up, you get 720. Let's move on to the next example. As we've seen the pattern now, we need to figure out the total angle sum of this. So it is a 1, 2, 3, 4, 5, 6, 7. It's an 8-sided polygon. So 180 times 8 minus 2 is 6. It's going to be 1080 degrees. So all of these angles, C plus the sum of all of these angles, so 90, let's add this up, 90 plus 135 plus 55 plus, little trick here now, this angle is 90, but that's on the outside of the shape. We need to figure out what's on the inside of the shape. So that bit that I've highlighted must be 270 plus another 90 plus 120 plus 220. This gives us 980. So 980 is the sum of everything else. Well, subtracting this, so 1080 minus 980 gives us 100 degrees. So C equals 100 degrees. And once again, I apologize for my drawing. That is still an acute angle. It should have been out more like this. So yeah, should have been more like this. Regardless, the math and the concepts remain the same, even if the drawing doesn't quite match what it looks like. All right, let's keep going here. Let's count how many sides first. 1, 2, 3, 4, 5, 6. Well, if we calculate that again, it'll be the same as this, because this is also a 6-sided shape. Okay, so we know that it will add up to 720. So the sum should equal 720. But once again, if we calculate and count carefully, it's 90, 90, 90. This one here is not 90, because that's on the outside of the shape. That's going to be 270 and 60. So it's 3 lots of 90 plus 1 lot of 60 plus 270. So adding everything up, we get 600. And D is the missing letter. Well, this is nice and simple. We can figure out that D must be 120 degrees. All right, last 2 examples. This one, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a regular decagon. It's going to be 180 times 10 minus 2 is 8. The angle sum of this, oh, I can't calculate that quick enough in my mind, so I'm just going to use my calculator. That should add up to 1,440. Once again, similar to the regular hexagon, there are 10 equal angles of E. So 10 times E is 1440, meaning one lot of E is going to be 144 degrees. All right, last one. Once again, counting the sides. 1, 2, 3, 4, 5, 6, 7, 8, 9. So all of these add up to 9. So 1080 times 9 minus 2 is 7. Gives us 1,260. Now the interesting about this is I've drawn this so that it is perfectly symmetrical on the top and on the bottom. Meaning, if this is 50, this must also be 50. If this is 70, this one must also be 70, and so on. And one final thing to look out for is that this 60 degrees is on the outside of the shape, which means this on the inside is what we're looking for. All right, so let's calculate this. Quickly adding these up, there's going to be 2 lots of 50, 2 lots of 70. This one should add up to 360, so this angle here should be 300, 2 lots of 300, and 2 lots of 30. So 50 plus 70 plus 30 plus 300 should be 2 lots of this. So all of this should add up to 900. So F plus 900 equals 1260. So 1260 minus 900. Minus 900. My goodness, my drawing is definitely not correct because that should be a full revolution. Let's just quickly increase this by 60. So 60, 460 minus 920. This gives us 340 degrees. There we go. So I apologize with the numbers and the weird looking acute angles, but hope you can see how this formula is used and how we can apply it in the same way that we did for the other triangles and quadrilateral internal angle sum. So I hope to see you in the next video, and best of luck.